When reclassifying Class 2 or Class 3 circuits to Class 1, specifically using 14 American wire gauge THHN conductors for installation within the same raceway as power conductors, the National Electrical Code (NEC) mandates adherence to specific safety measures. It is essential to install overcurrent protection as stipulated in Section 725.23 of the NEC. The purpose of overcurrent protection is to protect the circuit conductors and connected equipment from excessive current, which could result in overheating, insulation damage, and potentially electrical fires. When a Class 2 or Class 3 circuit is reclassified as Class 1, it effectively adopts the characteristics and requirements of a Class 1 circuit. This reclassification necessitates compliance with all relevant provisions of Article 725 and other applicable articles within the NEC. Section 725.23 specifically addresses overcurrent protection for Class 1 circuits, outlining the criteria for selecting and installing overcurrent devices such as circuit breakers or fuses. The overcurrent protection must be sized appropriately to protect the 14 American wire gauge THHN conductors used in the reclassified Class 1 circuit. This sizing is crucial to prevent damage to the conductors in the event of an overcurrent condition. The ampacity of the 14 American wire gauge THHN conductor must be determined based on the allowable temperature rating of the conductor and the ambient temperature conditions. NEC Table 310.15b16, formerly Table 310.16, provides ampacity values for various conductor types, including THHN, based on conductor size and insulation temperature rating. The overcurrent protection device must be rated at or below the ampacity of the 14 American wire gauge THHN conductor, as corrected for ambient temperature and any applicable derating factors. Derating factors may be necessary if the conductors are installed in a raceway with other current-carrying conductors, or if the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit. The NEC provides guidance on applying these derating factors in Section 310.15. In addition to sizing the overcurrent protection appropriately, it must be installed in a readily accessible location and be properly labeled to identify the circuit it protects. This labeling is essential for safety and facilitates troubleshooting and maintenance. The overcurrent protection device must also comply with applicable product standards such as those established by Underwriters Laboratories (UL). These standards ensure that the overcurrent protection device is tested and certified to meet specific performance and safety requirements. Furthermore, the raceway in which the Class 1 circuit conductors are installed must be properly sized and installed in accordance with the NEC. The raceway must be large enough to accommodate all conductors installed within it, including the power conductors and the reclassified Class 1 circuit conductors. The raceway must also be installed in a manner that protects the conductors from physical damage and environmental conditions. When installing the Class 1 circuit conductors in the same raceway as power conductors, it is essential to maintain proper separation between the different voltage systems. This separation helps to prevent the risk of electrical shock and ensures the integrity of the insulation on the conductors. The NEC provides specific requirements for separating different voltage systems in raceways in Article 300. Grounding is also an important consideration when reclassifying Class 2 or Class 3 circuits to Class 1. The Class 1 circuit must be properly grounded in accordance with Article 250 of the NEC. Grounding provides a low impedance path for fault current, which helps to protect personnel and equipment from electrical shock and damage. The grounding conductor must be sized appropriately for the circuit and must be connected to a suitable grounding electrode system. Bonding is another important aspect of electrical safety. All metallic enclosures, raceways, and equipment associated with the Class 1 circuit must be properly bonded together to create a continuous electrical path. Bonding helps to minimize the risk of electrical shock and ensures that fault current can flow safely back to the source. The bonding jumpers must be sized appropriately and must be securely connected to the metallic enclosures, raceways, and equipment. Before reclassifying a Class 2 or Class 3 circuit to Class 1, it is essential to carefully evaluate the existing wiring and equipment to ensure that they are suitable for the new classification. Existing wiring may need to be replaced with conductors that are rated for the higher voltage and current levels associated with Class 1 circuits. The existing equipment may also need to be upgraded to meet the requirements for Class 1 circuits. It is also important to consider the impact of the reclassification on other electrical systems and equipment. The reclassification may affect the overall electrical load on the system and may require adjustments to the electrical service or distribution system. The reclassification may also affect the operation of other equipment connected to the electrical system. Therefore, it is essential to carefully plan and coordinate the reclassification with other stakeholders to ensure that it is done safely and effectively. In addition to the technical requirements of the NEC, it is also important to comply with all applicable local codes and regulations. Local codes may impose additional requirements or restrictions on the reclassification of Class 2 or Class 3 circuits to Class 1. It is also important to obtain any necessary permits or approvals from the local electrical inspection authority before commencing the reclassification work. Finally, it is essential to use qualified and experienced electrical personnel to perform the reclassification work. Electrical work can be dangerous, and it is important to ensure that the work is done safely and in accordance with all applicable codes and regulations. Qualified electrical personnel have the knowledge, skills, and experience necessary to perform the work safely and effectively. They can also identify and address any potential hazards or problems that may arise during the reclassification process. When working with electrical systems, it is important to follow all safety precautions to prevent electrical shock and other injuries. Always energize the circuit before working on it, and use appropriate personal protective equipment such as rubber gloves and safety glasses. Test the circuit to ensure that it is energized before working on it. Be aware of the potential hazards associated with working with electricity and take steps to minimize the risk of injury. When reclassifying Class 2 or Class 3 circuits to Class 1, it is important to document the changes that are made to the electrical system. This documentation should include a detailed description of the work that was performed, the materials that were used, and the test results that were obtained. The documentation should also include a revised electrical drawing that accurately reflects the changes that were made to the electrical system. This documentation is essential for future maintenance and troubleshooting and can also be helpful in the event of an electrical inspection. In summary, reclassifying Class 2 or Class 3 circuits to Class 1 requires careful planning, execution, and documentation. It is essential to comply with all applicable codes and regulations, to use qualified electrical personnel, and to follow all safety precautions. By following these steps, you can ensure that the reclassification is done safely and effectively, and that the electrical system continues to operate reliably and safely. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes for specific requirements and guidance. Furthermore, consider the environmental conditions where the conductors are installed. High ambient temperatures can reduce the ampacity of conductors, requiring adjustments to the overcurrent protection. Also, ensure that the raceway fill does not exceed the maximum allowed by the NEC, as this can also lead to overheating and reduced ampacity. Proper labeling of the reclassified circuits is essential for future identification and maintenance. Clearly label the circuit breaker or fuse protecting the circuit, as well as any associated equipment or junction boxes. This will help prevent confusion and ensure that the correct circuit is de-energized during maintenance or repairs. When selecting overcurrent protection, consider the interrupting rating of the device. The interrupting rating must be sufficient to handle the available fault current at the point of installation. This is especially important in commercial and industrial settings where fault currents can be high. If the interrupting rating is too low, the overcurrent device may fail to clear a fault, leading to equipment damage and potential safety hazards. Regularly inspect the reclassified circuits and associated equipment to ensure that they are in good condition. Look for signs of damage, such as cracked insulation, loose connections, or corrosion. Address any issues promptly to prevent further deterioration and maintain the safety and reliability of the electrical system. If any modifications or additions are made to the reclassified circuits, be sure to update the documentation accordingly. This will ensure that the electrical drawings and other records accurately reflect the current state of the electrical system. Keep the documentation readily accessible for future reference. Proper grounding and bonding are crucial for the safety and performance of the reclassified circuits. Verify that all grounding and bonding connections are secure and that the grounding electrode system is in good condition. Test the grounding system periodically to ensure that it is providing a low impedance path for fault current. If the reclassified circuits are used to supply sensitive electronic equipment, consider using surge protection devices to protect the equipment from voltage transients and surges. Surge protection devices can help to prevent damage to electronic equipment and extend its lifespan. Select surge protection devices that are appropriate for the voltage and current levels of the reclassified circuits. Finally, remember that electrical codes and standards are constantly evolving. Stay up to date on the latest changes and revisions to the NEC and other applicable codes. This will ensure that your electrical installations are always in compliance with the latest safety requirements. Consider attending continuing education courses or workshops to enhance your knowledge and skills in electrical safety and code compliance. These courses can provide valuable insights into the latest changes to the NEC and other important topics. When planning the reclassification, consider the long-term needs of the electrical system. Will the reclassified circuits be sufficient to meet the future demands of the building or facility? If not, it may be necessary to install additional circuits or upgrade the electrical service. Plan for future growth and expansion to avoid costly and disruptive changes later on. When selecting conductors for the reclassified circuits, consider the type of environment in which they will be installed. If the conductors will be exposed to moisture, chemicals, or other harsh conditions, select conductors that are specifically rated for those environments. This will help to ensure the longevity and reliability of the electrical system. If the reclassified circuits will be used to supply critical loads such as emergency lighting or life safety systems, consider installing a backup power source such as a generator or uninterruptible power supply (UPS). This will ensure that the critical loads continue to operate even in the event of a power outage. When installing the raceway for the reclassified circuits, consider the routing and support of the raceway. The raceway should be routed in a manner that protects it from physical damage and environmental conditions. The raceway should be properly supported to prevent sagging or movement. Use appropriate hangers and supports that are designed for the type and size of raceway being installed. When making connections to the reclassified circuits, use appropriate connectors and terminals that are rated for the type and size of conductor being used. Make sure that the connections are tight and secure to prevent overheating and voltage drop. Use a torque wrench to tighten the connections to the manufacturer's recommended torque. When testing the reclassified circuits, use appropriate test equipment that is calibrated and in good working condition. Follow proper testing procedures to ensure that the tests are accurate and reliable. Document the test results and keep them for future reference. When troubleshooting the reclassified circuits, use a systematic approach to identify the cause of the problem. Start by checking the basics such as the power supply, circuit breaker, and wiring connections. Use a multimeter or other test equipment to measure voltage, current, and resistance. Consult the electrical drawings and other documentation to help you understand the circuit and identify potential problems. When making repairs to the reclassified circuits, use only approved parts and materials that are compatible with the existing electrical system. Follow proper repair procedures to ensure that the repairs are done safely and effectively. Test the repairs to verify that they have corrected the problem. When working with electrical systems, always be aware of the potential hazards and take steps to minimize the risk of injury. Follow all safety precautions and use appropriate personal protective equipment. If you are not qualified to perform electrical work, hire a licensed electrician.